During the cold winter season at sea, electric heating cables installed on pipelines and equipment, along with temperature control systems, form a complete system. This system adjusts the operation of the electric heat tracing system based on monitored temperatures, generating heat to compensate for the heat loss of the medium caused by external low temperatures. It ensures the proper flow and storage of the medium within the pipelines, equipment, and storage tanks at the required operating temperature. To eliminate safety hazards that affect helicopter takeoff and landing, electric heating cables are typically installed in the interlayer between the helicopter platform. The temperature control system detects the temperature and humidity on the helicopter platform to determine the presence of snow accumulation and icing. Once the conditions are met, the electric heat tracing system is activated to melt the snow and ice, ensuring safe helicopter operations during takeoff and landing. Electric heating cables, in combination with temperature control systems, are typically installed on decks, gangways, and other areas where personnel move or stay, as well as on lifeboat decks and other emergency escape areas. They generate heat to melt snow and ice, thereby preventing safety accidents caused by personnel movement in normal or emergencies. In extreme cold environments, the drilling rig manifold serves as the main pipeline for transporting crude oil. To ensure the proper transportation of crude oil at the desired temperature, the electric heat tracing system becomes the preferred option. Its heat output prevents issues such as increased viscosity and decreased transmission efficiency of crude oil due to low temperatures. When combined with a temperature control system, it can enhance drilling efficiency and oil recovery. The crude oil extracted and the chemical raw materials produced during the manufacturing process, especially those with high viscosity, high consistency, and high wax content, are affected by environmental temperatures during transportation through pipelines to various processing stages. Electric heating cables, controlled by a temperature control system, generate heat to compensate for the heat loss of the medium, reducing its viscosity and ensuring its smooth transmission through the pipelines. The storage and retransmission of crude oil and chemical substances are also affected by temperature conditions. The storage units typically involve large containers, such as storage tanks. By conducting precise calculations and ensuring effective heat tracing, suitable electric heating cables and temperature control systems are selected to maintain the desired temperature. To prevent a series of fire safety issues, such as non-functioning fire hydrants, frozen and cracked fire pipes, and blocked fire pipelines, an electric heat tracing system can be introduced. With the detection of ambient temperature and pipe temperature, even in low-temperature environments, the water inside the fire pipelines can remain in a flowing state at all times. In narrow spaces, such as subway and high-speed railway tunnels, the frequent passage of high-speed vehicles creates localized strong winds and low temperatures. As a result, the water supply and drainage pipelines installed on the inner sides of the tunnels are exposed to long-term low temperatures and high pressures. By deploying and utilizing an electric heat tracing system, the freezing of potable water and sewage inside the pipelines can be prevented, thereby eliminating safety hazards such as pipe freeze fracturing. Under the dual carbon goals, the new energy industry is experiencing development opportunities, and solar thermal power generation has become one of the important and increasingly popular forms of power generation in the new energy sector. In solar thermal power plants, ensuring the normal flow and heat exchange of the thermal storage media, such as molten salts and heat transfer oils throughout the entire circulation process, is crucial to the operation of the solar thermal power plant. The heat exchanger is a crucial component in the entire molten salt system, responsible for heat exchange. Therefore, it also requires the use of electric heating cables for temperature preheating and temperature maintenance, ensuring effective heat transfer. In regions with abundant solar resources, such as northwest China, where there is a significant temperature difference between day and night, and considering that the normal operating temperature of molten salt is close to 300 degrees Celsius, it is necessary to use mineral-insulated tracing cables to elevate the pipeline temperature and ensure the flow of molten salt at the desired operating temperature. Under the control of a PLC temperature control system, the heating cables can heat the empty pipelines to the specified temperature within a specified time frame and maintain it. This ensures that the molten salt is not affected by external temperatures, enabling its flow within the pipeline and normal heat exchange. In an age of breakthroughs, the only certainty is change.